So, what I'd like to talk to you about is responsible AI and an open source library that you can use today to evaluate LLMs, compare them, and make sure you get to production safely. Responsible AI today is not optional. It's not a nice to have it here on top. Most of my work is in healthcare. Generally, in healthcare and life science, it is illegal to go to production like with one patient or one customer before we actually proved in writing and validated that you're not going to hurt someone. But even in other area, we have cases. This is now people are being sued as we speak. Whether you are in e-commerce, you cannot offer different prices to white people and black people. Same thing for recruiting, consumer protection, banking, credit decisions. You need to be able to prove that you are doing things correctly, that you are not violating laws that are already existing to protect the populations. So in order to to tell the world that everything is okay, basically every company, every large company came out with this beautiful graphic that says, our AI, it's ethical and it's human-centric and it's responsible and et cetera, and very quickly we had more of these. And then we had more of these, and really there's no large company or consulting company or government organization does not have one of these like beautiful things. But the problem is, what do we do when we actually go and implement the system? And if you read just about every paper that comes out on the topics of robustness, bias, fairness, toxicity, truthfulness, data leakage, what you find is basically, and this is, by the way, the same thing I'm seeing right now kind of in practice in production, the situation is really, really bad. You take a prompt, you change one character, it breaks. You test it, males versus female, white people versus black people. You look at data leakage, you try to protect the information, you find it. The one thing that's common to many of the papers of this year, all of them say, here's what we found, and in the discussion section, this is really not surprising because we are the first ones to ever check. Okay, and what we need to go really beyond that step now. So here are some things that we have learned that you need to pay attention to when you deploy systems. So here, things that you need to do. First of all, you need to actually test your models, whether they're classic ML models or LLMs. So really right now, especially with LLMs, we are kind of where we were with software engineering in the 80s. I code the thing, it sort of works on my machine, okay, push it, right? And then we learned that there's this whole theory and practice of software testing that goes through many, many layers and has many, many tools so that we actually know that when you say something works, it actually works. And now we're at the point where we need to do this. And if we don't do this, really, there's no surprise that the situation as it is today. The other thing we need to do, which also is obvious once you write it, you have to test beyond accuracy. Okay, if you want a system to be robust, right, to be able to deal with typos, right, or the fact that you change the order of words, if you want it to deal with bias, if you want it to not leak protected information, if you want it to not be toxic, you actually have to test for this stuff, right? And just like we have unit testing with every version before it goes to production, you need to know that you're safe. There are two important things that we've learned that you cannot do, because we actually deploy this for real customers and get feedback from them. The one thing you should really never do is pick a model that someone published with a paper, someone published a checkpoint, kind of said, this is my model, it has the best F1 score, it's really great embeddings, I'm just going to go with it. Okay, basically we find these models, usually they perform okay on the F1 score, not always. Generalization is something to usually test. But in general, the current standard on how they perform on any other requirement and any other metrics you look at would be far below what you'd normally expect. So that's one thing I can tell you, just never do this. The second thing you do not want to do, you do not want to rely on standard benchmarks. Okay, so if you know, for example, Stanford, they have a great project called the HELM, Holistic Evaluation of Language Models. There are lots of benchmarks for toxicity, for truthfulness, and there are two problems with it. One problem is what a lot of companies and systems do today. They do what's called classic overfitting, which is they train the LLM on those tests. Okay, and then what you get, of course, you perform beautifully on the test. Yes, you test on your training data, that's fantastic. And really, then what you say, like really change one word in the prompt or one word in the data, and then the thing completely fails. The other thing that you get is really general robustness issues. Okay, and really I have an unproven hypothesis that a lot of the gains that we see now with very large language models compared to the same models, 500 billion parameters or 50 billion parameters, is really the model that just memorize more of the web. Okay, and if you give it a medical test or a legal test, it's just very likely they actually have the exact copy of the same test and it can just give you the answer. Which is not what you want to see when you want to have a generalized model. So to deal with some of the issues, one of the things we've done at Johnson Labs, we've built the NLPTest library. and this is completely open source. It's Apache 2.0 license. Use it, abuse it, take it, do whatever you want with it. It's open for commercial use. The goal is to have something that's very simple, so as you'll see in a few lines of code, you can tell it, please generate tests for me, and right now there's, I think, about 60 plus somewhat types of tests that it can generate automatically. You can also do things manually if you want to. Testing also is something that you don't need to be a data scientist to do, right? You really want to be like really an end user or kind of a domain expert to be able to come and say, here's how I test something, just like classic software testing. We want it to be comprehensive, so actually test in one place everything that you want to test before you're ready to go to production, and of course make it open source. So the NLPTest library does 3 things for you. So instead of the current path, which is you train your model, accuracy looks good, F1 score seems to be stable enough, push it to production. We want to add 3 steps. We want to generate some tests, then we want to run the tests and get a pass-fail score, right? And this is something we need embedded in our release or MLOps pipeline. And in some cases, we want it can also do some data augmentation, okay? So that we can automatically add more training data and improve the model. So let's see how this looks like in practice. So these 3 lines of code show you really the whole thing end to end. From NLPTest, we import the library. Then we create a test harness, which is an object. And you basically tell it, look, I want to test this model. In this case, we're testing the most widely used model on Hugging Face, or a BERT-based case from Hugging Face. You can also specify the tests that you want to use, but there's a default test set for each task. So whether you're doing NER, or you're doing classification, you're doing question answering, you're doing summarization, they're kind of standard test sets that you start from. And then you use the harness. So you tell it to generate tests, okay, which means start with the test set that I gave you, but it's a kernel. Generate other tests from it, and we'll see what kind of test you can generate. Once you generate the tests are just available as a Python data frame. You can export them as a CSV, you can add in Excel, you can load them, you can do whatever you want. Then you run the tests, okay, meaning actually run inference and see if each test passes or fails. And then just generate a report. Give me per category, how am I doing for each kind of test, and in the end, based on the config file I provided, did I pass or did I fail? In terms of what you can test, kind of the hubs you can use, so this is what's available right now out of the box. So you can test any Johnson Labs model, any Hugging Face model, any OpenAI model, anything that works with LangChain, Cohere, Open Assistant, AI21, OpenAI, of course, all the Llama and Llama variant models, so all of those are there. So those integrations are there, and also the way just the system is designed, if we add another kind of hub or another source of models, all the tests work. We can generate and run tests of all of those. And also if we add another test type, so for example, we recently added the toxicity tests, so now we can do toxicity tests on all of these together. Okay, so it's designed to separate those 2 concerns. And now let's talk about what you do. And the first thing you want to do is actually generate tests. Okay, and what I want to explain is what this means. So robustness tests basically want to show how your model performs if you make small changes to the input. So what happens if I introduce typos, spelling mistakes? What happens if I change the speaker? What happens if I change the time, right, from present to past? What happens if I add punctuation? What happens if I change a question to an answer or an answer to a question? Okay, can you still answer the question? There are different types of fairness tests. Okay, the simplest one would be, classify whether this is talking about a man or a woman. Then I want, for example, whatever accuracy metrics is, let's say F1 score. I want it generally, here's the minimum I want, that's a test. I want it only for male, it needs to be at least that. Only for females, it needs to be that. So that's kind of your basic fairness per group. There are different types of bias tests. And this is where you'll see a lot of things really failing. For example, names. So really, when we started the project, we actually had a real customer, and we were doing medical data de-identification, anonymization, and they let us know that, look, if you type in, Mike Johnson came and complained about, knee pain, it worked 99% accuracy. If it was an Asian name, like Wei Wu came and complained about knee pain, it was only at 91% accurate. Okay, so really it means made like 5-6 times more mistake, okay, with this group. And then when you look at this, you come and say, okay, it's a bug report, but really, first of all, okay, shouldn't we also check, white people, black people, Hispanic people, Jewish people, Muslim people, We have now tests here, for example, of Hindu people per caste, okay, because they're typical name per caste. We have first name, we have last names, so we can automatically do the kind of generation. As you can see on countries, we replace countries automatically, and there's UN lists of countries that are kind of richest, poorest, and then there are two more classes in between. We can look at it as per age group, per religion, and there are other tests that look at kind of specific biases, like young, old, rich, poor, but basically you can add adjectives automatically, so those are some of the other things that are there. And then there are accuracy tests, okay, because if you comprehensively test the model, yes, you also want to pick the most accurate model, or at least you have an accuracy baseline before you go to production. So we've implemented all the metrics around, your classic summarization metrics, question answering metrics, that's there as well. And we have representation tests. Okay, so for example, sometimes you can say, oh, I want the accuracy for women only to be at least 90%, but there's another thing. Sometimes what you find is you have a protected group and you don't even have 10 women in the test set, right? And you can say, look, I'm just going to fail this on just lack of representation. Okay, kind of go and work your tests as well. Overall, there are 10 categories of tests that are there. When you run the test, say you can generate the test and either automatically or you can edit them manually. And you can see the example here. So in the first row, we've added a typo. In the second row, we've added just some context, some hashtag. In the third row, we replaced kind of the name, right, to another ethnicity. In the other two rows, we look at representation and accuracy. Usually, even if in a simple case, once you generate a test, you can have really from a few hundred to a few thousand tests. Okay, and really the nice thing that's different from just unit testing on software to this is now we can actually generate a lot of these. And you can edit it, you can play with it, you can do whatever you want, you can save and load those tests. And then after you call run, we run the test, we run inference, and you call report. The report basically groups everything by category. And then in a config file, you tell it, okay, from this category, I want a minimum of 100% pass, 50% pass, 80% pass. And it tells you whether you passed or fail. Okay, and this is something you integrate as part of release pipeline so that every new version of the model needs to pass all the tests like any other piece of software. Okay, on top of that, if a regulator comes and says, oh, well, why do you think that this model is not biased? You can tell them, I'm happy you asked. Here are the tests, and I can give it to you as an Excel file, right? You don't need to be a data scientist. Here are all the things I've tested. Here are the benchmarks. Here's my release process, right? And I can show you that at least these baselines are being met. So you can generate tests, you can run tests. The other thing you want to do is data augmentation. Because if you think about it, look, if you can generate new tests with Hispanic names, black names, female names, first names, last name, country names, and you can show that the model is garbage or does not do as well, well, the next thing you can, okay, well, if you can generate all them, can you just add them to the training data and just retrain with that and give me a stronger model? And that's what augmentation wants to do. The only thing is what you cannot ever do is take your tests and use them to train the model because that is classic data leakage, right? You cannot then test on what you trained on because then, of course, it's going to do better, right? Yes, I trained it on the test material. So what age.augment does is it generates new examples only on the training data. So if you see here the example, age.augment, you give it your training data set, okay, not the test, it's separate. It generates new example, and you tell it where it needs to send the output. Okay, so I generate a new enriched augmented training data set for you. Then you train a new model, and then you can do whatever library, however it is you train or tune your model, that doesn't matter. And then what you do is you run a regression test. Okay, which means that I want to create a new harness with a new model, but I want to load the old tests. Okay, so you have that one-liner, and then you just call .run, and it does that. Okay, so that's basically the workflow here. And what we found is, especially on robustness and sometimes on bias, this is actually enough to solve quite a lot. Assuming, of course, that the protected groups really behave similarly, right? So it's really just a matter of text. What you can do now with this, we have been working on this for a few months now, including kind of real production use. I would say things to know. Right now, if you look at the current LLMs that are in the market, the baseline is very, very bad. Especially robustness, fairness, and bias. Situation is not good. If you're working within any regulated industries, please test what's going on so that you're not in a position next year or the year afterwards where people rightfully sue you. Okay, so at least you should test whether your stuff works. This is completely open source. We build this for you. And we use it internally. We have a full team on this. One nice thing with Johnson Lab is that kind of we're not, we're profitable, VC funded, just like this is our third open source project, so we know we can support it for several years. It's not depending on a grant, it's not depending on funding, it's not depending on anything. So we're committed to open source community, just like our other projects, to do this for the long term. And with that, thank you, and I hope you find this useful.
David, thank you so much for all the exhaustive capabilities and abilities for us to take advantage. Maybe Jon Snow knew nothing, but Joe Snow Labs definitely know their things. So that's very exciting. We have a couple of more minutes for one question. Okay.
Hi, so I work in AI ethics, and I wanted to ask you, you said don't trust the benchmarks, don't trust the model out of the box, but trust me. So why should I trust you, and why should I trust your test? I just want to know.
Oh, no, definitely do not trust me. I would not trust me.
Okay.
I don't know anyone. No, actually, my kids, no, forget it. No, this is an open source project. Okay, what you do here is you generate your own tests. Okay, so what we're saying, for example, you start with a question answering data set. Okay, usually if you take that, any of the data sets on Helm, you just run them, you're going to see better results than what your customer will see in practice. So here's what you should do. You can start with it, generate more tests with it. Okay, try different variation, try to break it in terms of once and try to see what happens. What I see is that often once you look at the bigger data set that you've built, right, nothing I did, right, you'll see that the results are worse substantially than what you'd expect in terms of ability to generalize, ability to really handle what you think would be trivial changes in code. And then you can tune your models, you can augment your model, you can fix that. I would say we do work in healthcare. Another thing we often do is we generate the tests, then we have medical doctors who look at them, okay? Because some of the tests they can say, oh, this doesn't make sense, like this will never happen. Some that says, oh, this is great, I want to add 10 more like this. So you can see them go in Excel, or they paste, they come and say, oh, try all the medications that are, don't done as pill, right? Like, all medications or devices, right? Yeah, because you present it differently, the dosage is different, it's gonna break. All I'm saying is, if you only rely on the standard academic benchmarks, okay, I think you'll be overly optimistic, okay? And I think really, and the main thing that's happening right now, I think really is overfitting, right? Because really right now, like if I want to show that my LLM beats all the academic benchmarks for healthcare, it's super easy. I just train an LLM on them, or tune an LLM on them, right? And it's going to do beautifully because it does a lookup, right, essentially.
All right, please give a big applause to David. Thank you so much for sharing your knowledge with us today.